Today's topic is windage from a tooling perspective. So here are the basic steps to windage success. First thing is to make sure a part is feased. Talk about that. We're going to eliminate as much warpage as possible through conventional means. We're going to determine a windage factor. Also have to determine a shrinkage factor along with that. We're going to morph the CAD, and then we're going to perform a windage check. So step one, we need to make sure a part is feased. And this doesn't have to be super in-depth, but the more in-depth the better. But a preliminary feasibility study is going to assure that the part is good for tooling. That you have sufficient sidewall draft, for example, that you have good rib to wall ratio, and some of this can be fleshed out in the Moldflow analysis as well. Obviously, you got to make sure you have proper fit and function, and it's also good to have the basic die draw and die pull directions identified at that point. That's step one. Once we have the part feased, now we want to go into analysis and try to eliminate as much warpage as possible. Reducing warpage, really comes from 5 areas. You got input from mold design, you get input from part design, material properties, process settings, and of course, as I mentioned earlier, simulation expertise. So we want to make sure we've got the gates in the right position and sized properly. We want to make sure we've got cooling lines in the right position and sized properly. We want to make sure that we look at part design modifications. We want to make sure that we've got good material properties. By process settings, we want to make sure that we don't have to hit a super small target to be able to get the warpage reduced as much as we can. So we run our analysis again, and it predicts a warp shape from the windage model, and then we can overlay that with the nominal geometry and start picking points off and measuring how far off we are. So that's one way to do it, is to pick points on an overlay and see if these deviations from the nominal geometry are acceptable. So we've got the windage factor now. The next step is to determine the shrinkage factor. And for this, you want to look at a lot of different sources, right? So Moldflow is going to have some results that can give you a shrinkage factor, like kind of a composite shrinkage factor in 3 directions. If your Moldflow material deck includes what we call CRIMS data, that's empirical shrinkage data. You can use that information to know what you can expect for shrinkage values over a wide range of processes. You can use published shrinkage data from the material supplier, and you can use your past experiences. So all of these factors should be considered to determine the different shrinkage factors in the different directions. And it's not always going to be the case that you're going to put different shrinkage factors in different directions. Here's a look at what Moldflow might predict if we pick a couple of points across the part, or I like to pick point pairs very close to each other across the part and get some idea of which areas are shrinking more, which areas are shrinking less. Of course, we want to try to minimize shrinkage variation as much as we can through gating and processing, but parts shrink at different rates, right? You can see that here. In this particular part, you have very high shrink rate in the middle, and lower shrink rate values around the periphery. In this particular case, fiber orientation was a big player, so we had to consider the shrinkage in the direction of the fibers versus transverse to those fibers. So in those cases, oftentimes you will see different shrink values in different directions. So once we've got the windage factor and the shrinkage factors determined, we go into morphing the CAD. Okay, so we're going to take an STL or a step model from Moldflow with the proper windage factor. We're going to export that. We're going to expand it. We're going to make sure it's expanded to the proper shrinkage factor, the nominal CAD that is. But probably the biggest part of this is to protect features for die draw. So we perform another windage check here. In the upper one was what we did in Moldflow world when we just used a Moldflow morph. Here's what we did when we had the full CAD morph. In this case, everything came in nice and flat. This one didn't have a whole lot of features on it, so it wasn't terribly surprising that we hit that one pretty well. But in cases where there are areas that we have to pay attention to die draw, that's not always going to be the case.